Okay, hello, welcome back. Today we're going to do a little complex question using trigonometry identity, Pythagorean identity. So this substitution method is not an easy one, but it takes a little bit longer to do. Now, before I start, please consider to subscribe this channel if you haven't done so. So now is 152 videos now so far for this channel. So if you subscribe it, you can access all those videos in one go. All right, so now we're going to find the suitable substitution methods. This is a very interesting question, how we solve this. So now, initially we thought maybe using the u equal to square root of 2x minus x, but that one doesn't actually work very well, so we're not going to use that. So we're not going to use the square root. So I'm going to use the trigonometry identity. So why use the trigonometry identity? Because we know if I have something to do with square root of 1 minus sine square theta become cosine square theta. So that's become cosine theta. So that's the very important consideration. Now, because the question is, if I have a square root, I want to use the Pythagorean theorem or Pythagorean identity to get rid of square root. But the problem is here, we don't have the square term. So what I'll do is I'm going to make up. So I'm going to rearrange the bottom, become a perfect square. So you can see here, the second bracket is perfect square, which is 1 minus x squared. So therefore, I can treat it as 1 minus something. So I'm going to let 1 minus x equal to sine theta. So x become 1 minus sine theta. Then I differentiate that. So become negative cosine theta. So when we substitute it into the equation, so obviously 2 I'll move out. Now the top is x become 1 minus sine theta squared. Then denominator is 1 minus sine square root, so then become cosine square, cosine theta. Then you also have the negative cosine, or move negative to outside, so the cosine cancel with cosine. Now it's a lot simple. You can see we don't have a square root surd form anymore. So we just have a 1 plus sine theta square. We're expanding the bracket. So then we can easily to change sine square become half of 1 minus cosine double angle formula. So don't forget using the sine square. This is the first. Second of double angle identity is half of 1 minus cosine 2 theta. This is very useful. So we change to that. So we expanding the brackets. So that becomes 3 over 2 minus 2 sine theta. Then take away half sine cosine 2 theta. So we individually integrate it. So it become 3 expressions plus c. Now we simplify. So expanding the brackets times 2 inside. So become, that's the step here. Now, the problem is, we'll cancel this 2. The problem is we can't leave a theta. We have to use the x because the question is in relation to x. So we converted theta is the inverse of sine 1 minus x, then cosine theta. Now we know the sine theta is 1 over x. So if I say this is the trigonometry triangle, so you have an opposite over hypotenuse of sine, then adjacent is the hypotenuse take away the opposite, then square root. So that's a cosine. So the cosine theta will be square root 2x minus x squared. All right, so the cosine theta has become that. Then sine theta is 1 minus x. Cosine is square root of 2x minus x squared plus c. Then I'll put those two square root together. Then simplify to x plus 3 in the bracket, and the first one, and plus c. That's it. We solved that question. It's a very interesting question. It is not easy to think in the trigonometry identity. It's a very useful technique to solve for hard with the square root expressions. I hope you enjoyed the video. If you do, please give us the thumbs up. I will see you next video. Bye.